Hello and welcome to another video. In this video we're going to be working on special array with x elements greater than or equal to x. And so in this one you're given an array of nums of non-negative integers, and nums is considered special if there exists numbers such that they're exactly n numbers or x numbers and nums that are greater than or equal to x. X does not have to be an element in nums. Return x if the array is special, otherwise return -1, and it can be proven that if nums is special, x is unique. So in this case, for the value 2, there are two numbers that are greater than 2, so you would return 2. For here, so it can never be negative because you can't have like negative numbers that are greater than your number. So because it's all zeros, it can't be anything. So essentially, because for 0 there's 2, and then for anything bigger there's 0. And then in this case, there are 3 numbers that are greater than or equal to 3, so that's what you would return. So it should be kind of straightforward here that you're going to want to sort your array because you're going to want to know quickly. Obviously, it doesn't really matter because it's an easy problem as far as like time complexity, like anything will pass. But like a brute force solution would be like, okay, if nums is 0 to 1,000, maybe I'll just try like for every single number 0 to 1,000, figure out how many numbers are greater than my number. And that's doable. So that is doable, but another way is just, and basically what that would look like is you would just, for 0, check how many numbers are bigger. For 1, check how many numbers are bigger. And so the time complexity of that would be like 1,000, worst case, times the length of the array, which is like 100, which wouldn't be great. So here you can see that the numbers in here are bigger than the length of the array. So you're going to want to focus on doing something with the array and not just like brute forcing through any number possible. You could, I guess another way I can think of is maybe like binary search. Possibly, maybe that would speed it up. So instead of going through every number, you can check like, okay, maybe I will say, so I know I'll try 0 to 1,000, but maybe I'll try 500, and there's like, 200 numbers that are bigger than 500. So I need to make it smaller, and so on and so on. So I think something like binary search would actually work. But the easiest way is doing a sort. So what we can do is we can sort our numbers here. And so let's go through this example. Let's go through example 3. Oops. Why is it doing that? Kind of annoying. Okay, there we go. So we have something like this. And we're basically going to have a few cases here that can happen. So there's going to be a few cases. Case 1, the number we are on is the answer. Then we can just return it. Case 2, we can actually have a number that is smaller than our number. So it doesn't have to be exact, and I'll show you some examples of that. So the number we are on isn't the answer, but the answer is between that and last one. And I'll show you a couple examples of that. So in this case, here we can say, like, when we're on a number, we know right away how many numbers we have left based on the index we're on, right? So we know exactly how many elements we have left, and then we can just check, is our number the number of elements we have left? So for example, at index 0, we know we have 5 elements left because we're on index 0, and the number of elements we have left is the length of the array minus the current index. So that's pretty straightforward. So here we can be like, okay, we have 5 elements left. So if this is a 5, then we know we have our answer. And we also need to make sure that this is the first 5 we've seen. Because let's say we have like 5, 5, 5, 5, 5, and we're on this one, and we have 3, let's say we have something like this. So here we do have 5 elements left, but we have all these. So we have to make sure that if the number we're on is the answer, there are no other 5s before this. Otherwise, it can't be. So the only number we have to check is the first one out of, like, if there's a bunch in a row, we only have to check the first one. So for this 0, we'll say, okay, so there's 5 left. Is it a 5? No. But because this is in increasing order, maybe we can have a 5 that's an answer. But we can't have a 5 because the 5 actually has to be less than the current number we're on. And I'll show you why that is later. So for 0, this can't be the answer. And then, like I said, for the second 0, we don't need to check it because if 0 was the answer, it would have been true right away. And here, this is not going to give us like the right amount of elements left. So we're going to go to the next unique number. Now we check again. How many elements do we have left? We have 3, and we're on a 3. So we just return 3. So that's pretty straightforward. Like, if you have a number that's in your array, you just return that. And then that'll always work. And you only check, like, the first occurrence of every number. Because, like I said, imagine if we had this. We'd go over here. We'd say, oh, we have 4 left, and we have 3. That doesn't match. And then here, oh, we have 3 left, and we have a 3. But really, we have 2 3s. So really, for 3, there's 4 elements greater than or equal to a 3. That's why you only check the first one. So now let's look at a couple cases where, or maybe at least one case, where the number isn't the exact number, but it's like in the array. So maybe, let's see if they have some of these examples. I guess let's look at this example. Guess this works. Okay, so let's take a look here. So for 0, like I said, it's not going to work. For 1, we're going to say we have 3 elements left and we have a 1. So that doesn't work either. So the only way the number can be, the number we can have has to work is that number has to be between our current element and the one before. So it can't be 1, it can't be 0, but it has to be between those. Because if it was greater than 1, then there wouldn't be this many elements left, right? Like if this number, let's say, was like 3, well, there wouldn't be this many elements left because there would be only these 2. Because we have to include this number, right? So this number has to be greater than or equal to this number. And also this number has to be less than this number. Because if our number was like 0, then there wouldn't be this many elements left either. There would be this. So the number we're looking for is basically in between these 2. So we're saying, is there a number in between these 2 that works? And the number we're looking for, we know exactly what we're looking for at every index because we know how many elements are left. There's 3. So we're basically saying, is 3 less than 1? And is it in between these 2? And obviously not for this. Okay, so let's go to the next one. So here we have 2 elements left. So first we check, we have 2 elements left. Is 2 equal to 3? No, it's not. Okay, well, is 2 in between 3 and this? And it is. So that means that if we use 2, we're not going to include any of these. And we are going to include all of these. So we would return 2. So that's kind of the 2 cases you have to check for is we're only going to check unique numbers, and when we're on a number, if our number matches the elements left, that's fine. But also if the number we need, like 2, is between these 2, then that's another solution. And so that will basically, it's always going to be one of these 2. So maybe we can look at like one more case where it's in between those, but it should be kind of straightforward why that is. So maybe we'll look at like something like this. So here, 0 doesn't work, 0 doesn't work. Then here we have 6 elements left, so obviously it's not going to be a 1 or less than 1, so we don't need that. Here we have 5 elements left, so it's not going to be 3 or less than 3 because we're looking for a 5. Here we have 4 elements left, so it either has to be the 6 or between the 3 and 6, and it does work. So this should return a 4. And so that's how you can do it. Now, like I said, if this was a 4 already, this is why it has to be between, because here you could be like, oh yeah, 4 is less than 6, but it's not. It has to be strictly greater than this guy and strictly less than this guy. I mean, if it was strictly equal to this guy, then this would just be your answer. But it has to be less than this and strictly greater, because if we had a 4 here, then there's actually 5 elements that are greater than or equal to 4. So we have to have this count, but our number has to be less than this and greater than the one before. So those are kind of the 2 cases we're looking for, and pretty straightforward. And then if we don't find anything when we go through the whole array, we just return -1. So that's what we're going to do. So what we have to do is sort our array first. Then essentially we have to make sure that the only numbers we look at are unique. So if we have like 1, 1, 1, 3, 3, we only look at the first one and the first 3 and so on. So instead of using a for loop, we'll just use a while loop. So we'll just say like int I equals 0 while I is less than length nums. So this will make sure that like we're on a new number. So when we're on the new number, we have to check a couple things. So first we have to check how many elements do we have left. So we can say like int nums left or something equals, yeah, so this will be fine. Length nums minus I, like I said, because imagine your like length numbers is 5. We start at index 0, so you do have 5 numbers, and when you go to index 1, you have 4, and so on and so on. So if nums left equals nums I, you just return this. So that's one case. Now, another case is, let's say our number is, well, I guess this is a case we didn't look at. So let's say we have this thing, but instead of these numbers, let's say we have like this. No, let's not do that. Let's do this. Okay, so here the answer should be 3. Because there's 3 elements greater than or equal to 3. Same kind of thing. But here there is no element, like we're at index 0. So if we're at index 0, then our number has to be less than 4, but has to also be equal to this thing. So that's like a unique case, is if we're at index 0, we don't have to compare it to the number before. So we can say, we can probably combine this into two things. So we can say, like, if there is no number before, let's just make this some really small number so we know it's bigger. So maybe we'll make this like negative infinity. So it has to be bigger than negative infinity and less than 4. And that will combine our cases. And if there is a number before, then we'll use that number. So we can just combine that. So we can say like maybe num before or something equals, and we could say like I equals 0. If it is 0, then let's make it like negative infinity or something. Or I think all the numbers are positive, so we don't even need to use negative infinity. We can just use like negative anything. Yeah, all the numbers are positive, so we can just use like 0. I think 0 would be fine. Yeah. Okay, so we'll just use 0 here, and then if it's not, then we'll use the actual number before. So basically, if the number of numbers left is less than our current number and greater than the number before, then that's also valid. So we can say if nums left is less than nums I and nums left is greater than num before, then that number is also valid. It's not in our array, but that's the right answer. And I forgot a return statement here. And if we go through this whole thing, so a couple other things. So this handles like we're on a new number, we got something. Now what if that we don't have a solution? So if we don't have a solution, we have to make sure that we don't check any numbers that are repeating, right? So if we're on like a 6 and we have like something like this, we want to actually say, let's just go to the last 6 and then let's go forward one more to make sure we're not repeating. So let's handle that here. So we could say like while I plus 1 is less than like nums and nums I plus 1 equals nums I, let's just go forward. That way we'll be at the last occurrence of that number, and then we can go forward one more time. And finally, at the end, we just return like -1, I think, as a default. Oh, right. Not Python, so. Okay. Okay. Very nice. Yeah, so hopefully that makes sense, like the things you're looking for, how to check both numbers that are in the array and numbers that are not in the array quickly. Definitely, I mean, for an easy problem, a lot more intuitive solution would just be just brute force every single number possible. That's another way to do it. And yeah, so let's go through the time and space. So we're basically visiting every number once, and we're doing some couple calculations for it. So that's O of n log n, and space is O1. Yeah, so I think it's going to be all for this one. Definitely a little tougher than most easies. Maybe like an easier medium, I'd say. At least to do it efficiently. So hopefully this is helpful. If you have any questions, as always, please write in the comments, and I'll see you in the next one. So thanks for watching.